Very good afternoon, everyone. Thank you for joining us on this session on enabling a secure software supply chain for business resiliency. My name is Neil Pandya, and I'm the cybersecurity lead for Micro Focus here at APJ. I'm joined today with my esteemed colleague, Jeremy Chua, security architect here at Micro Focus, covering all areas of our security portfolio. A little bit about CyberRes. CyberRes is a line of business under Micro Focus. CyberRes is a line of business that we set up for this FY. So a year ago, we had some investment into our security portfolio, where we rebranded a lot of the capabilities that we have and invested very heavily in R&D for our security portfolio. So with that, let's get started. When we look at the supply chain, the software supply chain, there are many key components to the software supply chain. And let's have a look at how we look at protecting every single piece of that supply chain. So when we look at the supply chain, we start off by looking at how we actually enroll developers into our network and give them access to resource and services. That's the first thing. We hire a contractor or somebody from the development team to actually develop code for us. The first thing they need to do is to access resources within the network. Next thing they do is we provision them a workstation. Now, the question here is the workstation itself secure? Have we scanned for any vulnerabilities? Next thing we do is that a developer will install some tools for software development. That's what we hire them to do, and this is their role. So they'll need to install some tools to help them with the project in hand. The kind of things that we want to look for here is there any malware within the software that we're installing? Is it freeware? What about my software compliance? So a number of things that we want to check for here. The next part of this is the job in hand. The developer needs to write application code. So when the code is being written, how do we test the code for any vulnerabilities? Once the code's been written, it needs to be saved to a code repository. So again, what we want to do is to understand how the code repository is being accessed and whether it's been accessed in a normal fashion as we understand the behavior of the developer. Then once the code is ready, it moves into another environment, maybe further testing like a UAT or a system integration. Once the code moves into a further downstream testing, it finally moves into a production environment and the code goes live. What we're doing here is we're trying to understand the maturity of our software security assurance. Now, there are key components to this, and when we look at some of the vulnerabilities associated here, we start to address them with some of the technology that we have. So here at Micro Focus, within our CyberRes portfolio, we have an identity and access management solution, NetIQ, that helps us understand how the developer is accessing different types of resources and services within my network. And this is where we start to apply controls around access and have visibility on what's being accessed and how they're accessing that, and also resources as well as different types of applications. When we move into scanning for any vulnerabilities within our platforms that are being used by the developer to build code on, we can actually scan those assets, those platforms for any vulnerabilities. And we have, within our ITOM portfolio, we have technology which scans for known vulnerabilities. We can do automated patching as well. Very, very important to have that capability in place. Next thing we do is we actually control how a developer would install software on their workstation. For example, using MFA and OTP, every time some software is downloaded, we actually challenge the user for an MFA or an OTP. And this way, we ensure that it is the developer who's actually installing the software on their workstation, and it's not someone else doing that. And as the code starts to get developed, we start to test the code for vulnerabilities. My colleague Jeremy will talk a lot more about fortifying it. We'll go into a bit more detail about application code, application security testing, and how we can approach that. So here the code is being tested and scanned for any vulnerabilities, any known vulnerabilities, and we'll talk a bit more about that in the follow-up sessions, follow-up slides by Jeremy. The code's being written and it's being saved to a code repository. Now we have UEBA technologies, user behavior analytic technologies, capabilities, which understands and has a look at how a developer might be reading code from a repository as well as writing code to a repository. And we benchmark how that particular developer is behaving, and we look at new behavior patterns and we compare them to existing patterns to see if there's any anomaly and how much of a deviation is that from a normal behavior. We also compared that particular developer with their peers as well. So who else has access to this code repository or certain projects within those code repositories as well. This gives us an indication if there's any insider breach or somebody who's trying to inject vulnerabilities into the code that already exists in my code repository. For example, if I'm reading more code from the code repository than writing, there might be something in there that we need to look at. If I'm writing more code to a code repository than reading, there might be some vulnerabilities that I'm trying to inject into those projects. As the code gets tested, we move using our ADM portfolio, which is our application delivery management and Fortify. We can move the code into other environments downstream for further testing like UAT or system integration. But we do this in a very, very controlled manner. And finally, the code moves into a production and goes live. And again, we're using our ADM and Fortify to help us enable some of that as well. What this means is once we do this in its completeness, we actually arrive at a very strong compliance posture. The software is delivered with a higher security assurance, and we've also mitigated the risk from a number of different levels. When we talk about the software supply chain, it's very important to understand that although we talk about the Micro-Focus platform being able to fully secure the software supply chain, we can integrate this with whatever security technology you're using for your IAM or your user behavior analytics or your network monitoring. It doesn't have to be on the complete Micro-Focus platform. We can integrate with whatever you have. With that, I'm going to hand over to my esteemed colleague, Jeremy, to talk us through application security testing. Jeremy, over to you.
Yes, thanks, Neil. So good afternoon, everyone. My name is Jeremy. So I'm the security architect as well as the pre-sales manager for Southeast Asia region. So in addition to what Neil has just mentioned for the software supply chain, so I'll really provide a deep dive into a software security assurance for, in general, most enterprises. So it's surprisingly that when we talk to customers, so a lot of them are still running in silos. So what do I mean in silos? So they are running the software development and security is not built into or integrate into their software development life cycle. Right? But let us take a step back to understand how software development life cycle or methodology evolved. So 5 to 10 years ago, we are talking about waterfall model where it's very, very rigid and structured. Right. So in general, it will create some friction where we actually integrate security activities in it. Right. So pretty much the silo comes from doing security testing, right? Pre-production. So what this means? So out of 3 months or 6 months of works, it just perform a security testing at the pre-production phase. So what this means? It has a very short window time frame, right, for the developers and security team to work together, right, to resolve or mitigate those issues. This creates a lot of friction and induce a lot of inefficiencies and productivity. So the ramification of it is to release application with much more vulnerabilities in them. Right. So practitioners in the field understand, right? So what they really want to do is to build in security into those software development lifecycle phases, right? So I'll not delve into really those mindshare, but I really want to focus on the security part. Right. So today you heard a lot of terms like agile or DevSecOps. So the main objective of it is to shift left, right? So just giving mind on these 3 things. We want to test it early, we want to test it frequently, and we want to test it fast. I'll talk about the individuals into the various phases of the software development life cycle. Right. So in the very early phases of software development lifecycle, that's where the security requirements will be part of the software design requirements, right? So what we want is to have a secure by design, right? So the requirements will then translate to some testing where we actually also include security testing as part of the requirements and testing phase. Right. So after which we will have the coding or implementation phase where developers will start writing their code. They'll also leverage open source frameworks or components as part of their development life cycle. Right. Following which, if they're on Agile, basically it'll be a bi-weekly sprint. So they'll do talk about their features and do their testing bi-weekly, and followed by production, where they actually release their software. So moving back to the coding or implementation phase, this is the point where we really want to scan the source code to detect or identify insecure coding practices. Right. So this is really at the early phases of the software development lifecycle, where we really want to talk about shift left. Right. And a lot of our customers that we talk to are actually moving towards this direction, especially large enterprises. Right. So everything converge. So what do we mean by converge? When there's a time to market where business owners really need to release new features into the market fast. They really need to adopt Agile or DevSecOps. That's where they'll move towards new technologies or new methodologies, for example, microservices, as well as leverage Docker, right, or Kubernetes. So during this phase I mentioned, where we want to scan the source code, right, to identify potential insecure coding practices, we also want to scan the open source library to identify whether the vulnerability exists or whether the API that was used in the software development has a vulnerability, right? So this constitutes the static application security testing. So this is the activity that we really want to integrate as part of the coding or implementation phase. So moving next, where the application is built, which resulted in an artifact. That artifact will be deployed in the runtime environment, right? So for example, Java, you'll be deployed in the Java container like JBoss, Tomcat, or WebLogic. So for .NET, you'll be IIS, or it can be a standalone binary, which is for .NET Core applications, right? So once those applications are deployed, what they'll do is they'll also run functional tests, and they also run some load testing. So for this phase, what we want to do is we want to integrate dynamic application security testing as part of the software development lifecycle. So dynamic application security testing can be akin to like automated pen testing, where a tool will continuously automatically scans the website for attack surface and actually potential exploits. Right. So both SASD and DASD can be integrated as part of the continuous integration, continuous deployment delivery pipeline, right, which I'll touch on later on. On a high level, right, when we talk about automated platform, end-to-end application security, we do have Software Security Center as well as our 45 demand dashboard. So it creates a role-based access for various stakeholders. So once user log in, basically, according to their role, they were able to have a set of permissions, whether they can actually upload the results, review the results, or provide comments. So this is definitely very vital in terms of the remediation workflow. Right. So in particular, what I really want to discuss as part of this automated platform, right, is traditionally when I talk about silos, right, in a lot of organizations, how are those results being distributed to the developers, right? So a few years ago, when we talked to many customers, they are point-wise solution. So what do I mean by that? So for example, the security teams or the developers, after they perform the scan, what they will do is they will actually generate a PDF report, right? That will be distributed out to the various team members, including the security team. Right, that's one very important problem that they are facing. Right, if you're talking about one application, just one particular scan, definitely there's no issue. Right, but we need a solution that will be sustainable, manageable in the long run, because software security assurance it's a journey. Right. So we also need to understand the history. So the silos team, basically, they will use Excel files to manage those issues on the status. Right. We all know that in the long run, as more applications come in, as more scans come in, this will be unmanageable. That's where a centralized managed dashboard will provide a lot of benefits in terms of this. So 45 demand and Software Security Center basically provide this capability that I just mentioned. So for SASD, we have SCA, basically it's called the Static Code Analyzer. It supports up to 27 programming languages, and more will be added in the future as part of our roadmap. So we try to catch up with the market in terms of the new programming languages that are getting more used by a lot of enterprises. So The most common ones that we see in the market are Java, .NET. Those are the usual ones. So the new ones that are coming in basically are TypeScript, which most Node.js applications are based on, as well as Golang, right? So as part of the SASD, we also need to know what is the baseline standard that most organizations will be based on. So when we talk to a lot of customers, when we really advise them, unless they have a specific compliance that they need to adhere to, for example, PCI DSS or GDPR, so on and so forth, we usually advise, or most customers will take up OWASP as part of their baseline standard. In fact, 45 support all those standards that I just mentioned, and not only that, we support more categories than those standards. So we also provide the flexibility for customers to create new categories that they deem will be useful to their organization, or they can profile their applications based on those standards that I've discussed. So as part of DSD, we have this solution, which is Web Inspect. It basically does the dynamic application security testing on a runtime environment. So which is agnostic to the programming languages. So basically it has two phases. The very first phase is what we call crawling, or mapping out the attack surface. So you'll send a request to the server, which is a base URL that was provided, and you'll crawl from there, right, to map out the attack surface. So from there, basically, you identify what are the potential points that you can exploit. For example, HTTP headers, for example, HTML form fields, or even cookies. So from there, our backend analysis engine will kick in for various categories to send malicious payload to the server and study the response as part of the audit process. So from there, you determine whether it's true positive or whether an exploit did happen. So in addition to that, now more and more mobile applications are being created. So in addition to scanning of the source code of the mobile application, we also want to test the backend server, right? And testing the mobile app and the backend server is very, very different, right? So it requires a certain workflow, not like basically a web page where we can crawl. Because basically mobile applications will be using RESTful APIs to communicate with a backend server, right? So definitely there are certain automated flow for functional testers or quality testers to test the workflow. So all this can be captured as part of a proxy file. And this proxy file can be loaded into Web Inspect to run automated mobile application security testing for the backend servers. Right. In addition to that, our 45 on demand also provide manual testing on top of the backend server, basically taking the mobile application, install on a device and perform manual testing on that. So the next one is more on the architecture perspective, right? When number of applications scale, right? The backend application solution platform that we want to integrate in terms of application security must be able to scan. And to queue the scan, which is to line up the scan when more requests comes in, or to integrate with other technologies, for example, build tools, CI/CD, we have an approach of a centralized scanning. So various build jobs can communicate with the backend sensors or scanners through a centralized way, right? So not only that, we can also integrate with various build tools, for example, Gradle, Maven, MS Build, and so on and so forth, right? As part of the centralized scanning. So you're taking scan jobs and distribute to the backend scanners as well as sensors, right? So this is more of the carpet architecture, right? And not only that, it is pretty much easier to scale, right? If more demands come up, basically you have to speed up more sensors or more scanners. Right. So we all know that in terms of this, you can actually utilize Docker or Kubernetes to achieve this. Basically, you don't need a barebone VM, a barebone machine, or a VM to create a standalone sensors. So as part of the architecture, you can utilize Docker to spin up the scanners or sensors in a container on demand when a scan is required. So as part of the SASD, our technology partner, which is Sonatype, they do provide this capability. And all this that I mentioned can be integrated into the continuous integration, continuous deployment delivery pipeline. Right. So in addition to that, we do provide a single unified dashboard to view the SASD results and the SD results in the Software Security Center. We also want to provide developer-friendly tools that they can perform the scans in their IDE. So in particular, we do support some of the commonly used IDEs like Eclipse, Visual Studio, IntelliJ-based IDEs. So for example, PHP Storm and Android Studio, right? So I think developers are moving towards using Visual Studio Code, which we do also support. Right. So in addition to that, we also provide a real-time lightweight scanner. Basically, it's a spell checker like tool, right, for you to scan, for us to scan the code in real time as the developers type the code. So all these are provided as a plugin. We also provide plugins for continuous integration. Right. So as part of your build pipeline, you can integrate SASD and DSD into the pipeline as well. So some of the ready plugins that we do have will be Bamboo, Jenkins, Azure, DevOps. For those that we don't support, don't worry about that. We do provide some command line approach, or we do provide a wizard for you to generate script. So basically, you can trigger the script as part of your pipeline to trigger the scan. In addition to that, right, we want to know to scan by commit, right? So we do provide GitHub Actions that can perform that as well, right? So take a look at our GitHub repository or GitHub page. We do have some samples on that as well. So like I mentioned, a lot of organizations, they want to have that speed, but without the lack of security, right? So we do provide various type of scans that you can perform. For example, commit scan. So when developers commit their code, you'll trigger the scan, right? It's a matter of just a configuration. We also have speed down, right? So for the organizations to adjust the speed and the quality of the results that they want, right? So in all, we do provide the breadth and depth. We also provide the flexibility for our customers for them to embark on the journey in terms of their application security. And not only that, so most of the challenge when we talk to customers, they do have is as more applications get scanned, as more and more applications get scanned, right? The number of issues that they need to review is humongous, right? So Fortify does provide a solution called Audit Assistant. So it's a machine learning based auditing solution, right? Where the results from Software Security Center or from our Fortify on Demand will be submitted to Audit Assistant. And through machine learning algorithms, the predicted results are actually returned, right? Putting a threshold or a verdict on the results, whether it's a true positive or false positive, right? The whole of our FOD, Fortify on Demand platform, is using our Audit Assistant. So we have years and years and tons of results as a base of learning with our algorithm. So this actually reduces a lot of time, right? When security teams need to review a lot of issues under a short amount of time, right? So this also let them focus on more critical projects. So for less critical projects, they can actually use Audit Assistant for that matter. In terms of reporting and management, so both Software Security Center and Fortify on Demand provide the features to report, to generate reports. Those that I have mentioned earlier, for example, OOPS Top 10, SENS Top 25, PCI DSS, GDPR, ISO 27001, etc. Right. The dashboard also provide some key trending metrics. For example, the average days to remediation, the average days to audit. Right. So these are some important information for the management to know what is the progress in terms of their application security assurance journey. So let me give you a typical example. Why managing the issues is very important. So for example, I do have a development team, on the very first scan, which is the baseline scan. There are a lot of cross-site scripting issues being reported. Right. Generally, when developers get trained on secure coding, right, the number of issues being remediated will be reduced, and not only that, they pick up the habit of doing secure coding. So generally, you'll see a reduce in the number of issues for that category, right? For example, right. But once all these issues or the trending metrics are being displayed, you notice that whether this actually takes place, right? You see the progress, or in general your security posture for the application, or that or for your organization, right? And one very important thing that I want to mention is, regardless of how many times you scan, right? How frequent you scan, how fast you scan, it doesn't mean that the application will be secure. The application is secure after the issues or the vulnerabilities are remediated, right? So which means we need to enable the developers to write secure code, right? So as part of collaboration with Secure Code Warrior, so there's a direct integration with Software Security Center and our 45 on Demand dashboard, where developers will get access to content, to a gamified way of secure coding training, meaning they'll get a scenario for a particular category. They'll be shown with a piece of vulnerable code. So the solution, Secure Code Warrior, will also guide them to identify that piece of vulnerable code and guide them on how to remediate that piece of vulnerable code, right? So in particular, we not only we want to provide the best solution to with your journey of application security, we also want to train the developers, right, to adopt secure coding practices. So moving to production, we integrate with runtime application SelfProtection, which basically provide an agent installed on the application server. It instruments the application. By instrumenting the application, it understands certain context of the application. So it is not like web application firewall, which inspects the packet that comes into the network for example, through HTTP or HTTPS. So basically, runtime application SelfProtection scans the data that is coming directly into the application because it instruments it. So from there, once it detects malicious data, basically it can trigger into two types of actions, whether you want to protect it in real time, or you want to alert the send that alert to your SIEM solution. Right. So not only we want a proactive approach, we also have a defensive approach in terms of your application security journey. Right. So all in all, we provide an end-to-end with a breadth and depth of application security solution for all customers, not only for on-premises, not only for cloud, but also as a hybrid. So we do have some customers that run on-premises and our SaaS solution together. Right. So to end this, I would like to share with the audience that as part of our expansion and as part of our commitment to customers to get a better reach, we recently launched an instance for our 45 on Demand in Singapore. So the customers in the region will have a better reach of us. Right. So please scan the QR code for more info. Thank you.